Applications built with large language models typically rely on rigid, fracturing structures like retrieval augmented generation or vector databases to manage memory. These systems operate on predefined rules, categorizing and indexing information based on schemas established long before the data is actually processed. However, raw data itself has no intrinsic value. The same sentence can be meaningless to a child, yet critical to a scientist, because the value is dictated entirely by the intelligence processing it. This diagram illustrates two forms of fixed intelligence, a relational grid and a multidimensional vector space. When an LLM learns and outgrows these original structures, it hits a wall. The schema becomes a prison that restricts further reasoning. To build a system capable of continuous understanding, we must move away from databases constraining cognition and build systems where the intelligence itself is the schema. This is the Adaptive Memory Store, or AMS. The operating rule is straightforward. As the language model makes new logical connections, the system's structural architecture actively grows to match its understanding. Today, we map out the theoretical foundation of AMS version 1, building it from first principles. We define the specific data primitives, construct the reasoning engine, and trace the continuous execution loop. An evolving knowledge engine requires us to structurally model the language model's actual cognition. Current data ingestion relies on semantic chunking, making arbitrary cuts resulting in isolated text fragments. But AMS uses views. An active intelligence scans the text, isolating complete thoughts as atomic units. A view is an atomic picture of meaning, a self-contained unit that can be evaluated and understood independently of the rest of the document. Identifying these atomic pictures requires the active cognition of a language model, as a basic script cannot determine what constitutes a complete thought. Memory begins by parsing the world into these distinct, comprehensible units, rather than meaningless blobs. The second primitive is the place. Views are saved only when connected to current understanding. The view "rain helps crops grow" bridges existing rain and crops nodes. But atmospheric pressure finds no anchor, so it's diverted to a homeless data bin. Homeless data indicates that the language model's current structural footprint is not yet large enough to contextualize that specific piece of information. Vector space calculates a similarity of 0.82 between pressure and agriculture, confirming proximity but lacking causal understanding. Instead, active intelligence directly draws the causal path. Pressure leads to rain, rain provides water, water grows crops, and crops drive the economy. Identifying these logical patterns actively constructs new structural addresses within the database. Reasoning is the engine of schema construction. Only intelligence can build the logical roads required for deep memory. The continuous runtime loop begins with raw data flowing into the extraction engine. The language model pushes atomic views toward a placement gate. Contextualized views enter the mind network, while those lacking anchors drop into the homeless bin. Placing a view, the model determines optimal storage based on anticipated computations, actively expanding the mind's footprint. Finally, an arrow loops back, re-evaluating the homeless bin against this newly expanded structure. The adaptive memory store functions as a continuous, self-feeding computational circuit where reasoning drives the evolution of storage. This diagram displays the three distinct artifacts produced by an AMS run, providing a transparent map of the system state. The mind serves as a living document of connected understanding, where the language model has explicitly defined every relationship. The place data consists of information structured specifically for the computations the system expects to perform. The homeless queue holds raw data until a future system upgrade, such as a more capable LLM, provides the integration points needed to absorb it. These three artifacts provide developers with total visibility into the actual depth of the AI's comprehension. This architecture remains minimalist, requiring no complex optimization layers or external orchestrators. The entire foundation is simply the loop of extraction, placement, and reasoning. Scale and structure evolve as a natural byproduct of the system's cognition. In an adaptive memory store, growth is the intelligence, recognizing value it could not recognize before.